Hi, good afternoon, Girl Scouts. This is Lena, Volunteer Experience Manager with Girl Scouts, coming at you live again with another Trefoil TV. And today we're going to do another fun science experiment. So today we're going to make a DIY lava lamp. And this again is what I'm calling kitchen science. So these are things that you probably have in your kitchen or in your bathroom right now. So the supplies that we need today are food dye, food coloring again. And we need some Alka Seltzer, so this is something that people have in their bathroom for heartburn, and it's kind of like a medicine. And just vegetable oil. It could be vegetable oil or canola oil. We need a clear cylinder, so you could use like a water bottle, but I just have a glass. And we need some water. And I think that's it. So the first thing that we're gonna put into our glass is we're gonna fill it pretty full of oil, maybe a little more than halfway. And if you use a water bottle or a smaller cup, you don't have to use so much oil. So we're going to do a ratio of about 2/3 oil to 1/3 water. So I've got my oil in here, and what we're doing is we're making a lava lamp. So today we're going to learn about density and polarity. So oil is a non-polar substance, so it doesn't have a negative or positive charge. Water, just again, normal H2O, is a polar substance. The H2O is water, H2O is the molecule. So the two hydrogen atoms are positively charged and the one oxygen atom is negatively charged. So this means water is a polar substance. And when something is polar and non-polar, it won't mix. So we're going to pour our water right in. And you can see it just sinks right to the bottom. So it created some bubbles, but it's not actually mixing. So you can see there's a line. So we have water in the bottom and oil on top. And the reason that the oil is floating above the water is that oil is less dense than water. So density is how heavy, how much mass a thing has in a given space. So 1 cup of oil has less mass than 1 cup of water. Even though they both take up the space of 1 cup, oil is lighter and water is heavier, so the water sinks to the bottom and the oil stays on top. So this is why, like if you have salad dressing, the polarity makes it not mix and the oil floats to the top, so you have to shake it up before you can use your salad dressing. And so then to our oil and water, we're just going to add some food dye. So today I've just got red and blue, and we can see what happens when the red and blue mix. So I'll just do a couple drops of red, and they're going to start sinking. And I'm going to do a couple drops of blue, and they're going to sink. And so they fall in bubbles, and then they're going to kind of break through the surface tension between the oil and the water, and they should burst, and then the water should get dyed a mixture of blue and red, so we should get a purple lava lamp. All right, and so when the food dye bursts and it mixed with the water, the reason that it's staying in these beads on the oil is because it's water soluble, so it doesn't dissolve in oil, but it will dissolve in water. And to speed up that dissolution process, we're going to add Alka Seltzer. So again, just Alka Seltzer. And what the Alka Seltzer is doing is it's really causing the reaction. So I have a packet. They come in little packets like this, and you kind of break up the tablet. And then we're going to open it up, and we're going to put it in our cup. And the Alka Seltzer is effervescent. So effervescent means it's bubbly. It's going to make bubbles. The bubbles are like the lava lamp. And the bubbles are going to create CO2, which is carbon dioxide. And those carbon dioxide bubbles going to set off the reaction. So I'll kind of hold this up to the camera. I'm going to drop in my Alka Seltzer. And pretty soon we're going to see some bubbles. And that's our lava lamp. Can you hear it fizzing? So the CO2, the carbon dioxide, is attaching to the water, the H2O, and it's creating gas bubbles, which are less dense than the oil. So they're floating to the top, and then once they reach the surface, those gas bubbles pop and they float back down. So the water is less dense, so it floats through the oil, and then it's more dense, so it floats down to the bottom. And that is our lava lamp. So we learn a little bit about density and polarity. And you can see the different colors. There's actually still some red and blue bubbles, so they didn't mix completely. I wonder if you can hear the fizzing. So this is a fun thing that we like to do at STEMopalooza. This is also something you can do if you're working on your Brownie Home Scientist badge, or just a cool way to illustrate density and polarity, like I said. And it's almost done. It just takes a few minutes, and you can actually, if I wanted to make it go again, you can see what happens if I put in the other Alka Seltzer tab. So again, I'll just break it up a little. And here we go. It's even better the second time, I think. Has anyone ever done this experiment? If you have, again, we always like to see pictures or videos. And so, like, let's say you did this experiment in a water bottle, you know, like just like a disposable water bottle. You can put the cap on it, and you can keep this solution, and you can keep adding Alka Seltzer. You can do it many times. You can kind of do a cool trick to surprise your friends. I've still got some really light blue and some red bubbles in here. And then when you're done with this experiment, you can just, this we don't actually want to dump down the drain. If you have like an empty jar in your recycling can, then what you want to do is actually not recycle, you just want to throw away the oil. We don't actually like to pour oil down our sink drain because it's not good for our plumbing. But yeah, this is just a DIY lava lamp. And I hope you enjoyed it. I hope you make this experiment and you try it out at home. It's pretty fun. And if you do this experiment, take some pictures and drop them in the comments. And if you have any questions about Girl Scouts, you can always call or email us. And I just want to say thanks for tuning in and hanging out and doing some more science with me. Trefoil TV is going to have a break for a while as we switch into virtual programming, so I'm not sure the next time we'll do another video with everyone, but I've had a lot of fun doing these videos while we're all at home, and I hope you have a great day, and I will see you later. Peace out, Girl Scout.